All right, our discussion today will be more about our trig, but in relationship to something called the unit circle. So we're going to take all those trig values, the sine, cosine, tangent values that we've been learning, and now relate them using the 30, 60, and 45, which you hopefully have memorized by now, and relate them to what we've been doing. Okay. So we want to find exact values. We can do that. Use the properties of the unit circle. Since we now hopefully have those memorized, these activities will help us get them memorized if they're not. And remember, trig and the unit circle is what we're going to be talking about. So let's do a little quick double check with your trig functions. And do you have them memorized? If not, it's a little quick, easy recognition that you can put at the top of your paper. So if I said, what's the sine of 30, 45, and 60, and I put them in that order, okay, you should be able to go through and say, oh yeah, that's now the sine of 30 is the same as 1/2. The sine of 45, square root of 2 over 2. Sine of 60 is the square root of 3 over 2. And where those come from? Well, we learned that they also have what we call complement theorem. So the sine of 30 is equal to the cosine of 60. The sine of 45 is equal to the cosine of 45. And the sine of 60 is equal to the cosine of 30. So the complement theorem helped us. So if we don't have those memorized, it's going to be hard to travel around our unit circle that we talked about today. But luckily, the nice part of the unit circle today is we're only going to deal with our multiples of 90. So here we are on what we call a unit circle. I will do an activity with you in class today to do a little discovery. But notice I have positions, points, placed at 0 degrees, 90 degrees, 180 degrees, and 270 degrees. And then notice that my circle is marked in what we call quarter units. So I have 0.25, 0.5, 0.75. So if I labeled this green dot, I would be labeling it as the point 1, 0. If I labeled the green dot at 90, that would be the position 0, left or right, and up 1. So 0, 1. If I labeled the point the point negative 180, I'd be at negative 1 because I'm moving to the left of 0 and not up at all. So negative 1, 0. And then 270, the same thing. I'm moving not left or right, but I am moving one whole unit down. So I got 0, negative 1. So take a look at those ordered pairs. Not hard to determine, but we have talked in class now about what the x, y means and how we can travel. So here's a couple things. If I say, what are the signs, positive and negative, in the first quadrant anytime I graph? Most people would say plus, plus. You move to the right and you move up. Those are both positive units. If I moved anywhere on the unit circle, and it has to be on this arc, what would I be moving? Well, I'd be moving left and up. So left and up would be negative, positive. Anything in the third quadrant, what is it? Good, negative, negative. And anything in the fourth quadrant is a positive, negative move. So every ordered pair, we can go around and say, every ordered pair follows this setup. So it doesn't matter where we're at in that quadrant. And remember, quadrant 1, quadrant 2, quadrant 3, that's not negative, and quadrant 4. And these are Roman numerals we're using. Okay? And it always goes that way, never varies. There are no exceptions. The only exception some people would talk about is, what if I place the point on the circle here? Well, then, yeah, I'm not quite at 1. I'm not quite at negative 1. So we have some issues. And we're not going to be placing the point inside of the circle. So all our points are going to fall on the circle here as we go around. You can see that. Okay? So those are the exceptions. Now, if I would place those points, you're noticing right away 0 is in every single one of these. And 0 is tended to be considered not positive or negative. 0 is neutral. Okay, so keep that in mind as we move forward. All right. you should be able to, after our activity, find the sine and cosine. So let's double check. From the activity in class, we found that if theta is the magnitude of a rotation on the unit circle, then the cosine of theta, sine of theta, is nothing more than the 0.10 under a rotation of theta degrees. Now, when I say cosine of theta, sine of theta, we learned that always previously we were graphing xy on that coordinate plane. Well, now we found on the unit circle that the cosine lines up with the x value and the sine lines up with the y value, and they are actually one and the same. So when we go back to our picture of 0, 90, 180, and 270, and let's just stay right on those nice multiples of 90 right now, you should be able to tell me exactly what is the cosine of 90. So I can spin anywhere on this circle and say, oh yeah, cosine's x. Cosine is x and sine is y. So if you can't do that, that's what you got to memorize next. Now, here's a unique way to do that if you're having trouble. X, y, you have memorized because we've used it enough, but x, y was alphabetical order. Well, now, look at the same thing. Cosine, sine. It's alphabetical order. So we're not changing the rule any. All right, so if I ask, what is the cosine of 90? I'm really saying, what's the x value at 90? And that means at this point right here. All right, and so what's the x value there? 0. So what's the cosine of 0? 90. I'm not touching the calculator, doing anything with technology. I'm just saying that's the position I'm at. The cosine of 90 is 0. What's the cosine at negative 90? Well, same thing, just in the other direction. Oh, 0. Because I didn't move left or right again. That's the x value. All right, let's go back up there. I'm at 90 again. What's the sine at 90? You'll say positive 1. What's the cosine of 90? 0. Again, x and y values. All right, let's spin wide open. Here we go. If I say, what's the sine of 0 degrees? So if I rotate 0 degrees, where am I? Right where that green dot is at, 0 degrees. What is the y value at 0? 0. What is the sine at 270? Negative 1. What's the cosine at 180? Negative 1. Be careful now. What's the sine at 360? Zero. What's the cosine at 720? 1. So you have lots of combinations there. You're spinning and twirling, and that's what we expect you to do. And all you're going to have from this first section is what is the sine or cosine of 0, 90, 180, and 270. Now, let's break that up one last thing. What if I said, what's the tangent of any of those? So if I said, what's the tangent of 90? Your brain has to remember the tangent theorem says it's equal to the sine over the cosine. So your brain has to say it's the y value over the x value. So again, spin back to 90. What is the y value at 90? Most people would say it's 1. What is the cosine, the x value at 90? 0. What do you get when you take 1 and divide it by 0? Undefined. So our tangent of 90 is undefined. That's all you have to do. So you can do sine, cosine, and tangent, the three trig functions we're working with in this section, and you will be good to go. So not much, but plenty of questions. Might be bringing them to class.